current divider rule formula grade 12 physical sciences. Remember, current division happens only in parallel connection, okay? You don't have current division in series connections, okay? Current division happens only in parallel connection. So, if you are given the value of each resistor and the total current in parallel connection, 1. Use the following formulae if you only have 2 resistors in the parallel connection to find the current through each resistor. So, you can use this formula or this formula only if you have 2 resistors in the parallel connection. Okay, to find I1, you have this formula. Okay, I1 current through resistor R1. To find the current through resistor R2, you have this. Okay, we are going to see how to use these formulae. Okay, now number 2, use the following formula if you have 2 or more than 2 resistors in the parallel connection to find the current through each resistor. Okay, this formula. We are going to see how to use this formula. Okay, let's see an example. Find the current through each resistor in the circuit below. You are given this circuit. Okay, solution, you have R1 and R2. Okay, 2 resistors in parallel. This is parallel connection. They are in parallel. Okay, so you have a total current of 8 amperes. So you can use this formula because you have 2 resistors in parallel. You can also use this formula because you have 2 resistors in parallel. This one can work when you have 2, 3, 4, 5, and so on. So let's use this formula. Okay, to find I1, you are going to use this formula. Okay, the current through resistor number 1, I1. Okay, the current through resistor number 1 through resistor R1. Okay, so this is equal to, you have the total current flowing into the circuit is 8 amperes. Okay, this 8 amperes will divide at this point. Okay, part of current will flow on this branch, another part will flow on this branch, and then they are going to join at this point. Okay, now you have 8 amperes again. Okay, so the total current flowing into the circuit is 8 amperes. Okay, R2 is 4 ohms. Okay, over R1 plus R2. Okay, 4 plus 6. Okay, 6 plus 4. Okay, R1 plus R2. Okay, this is equal to, you can use your calculator. So you have 8 times 4 over 6 plus 4. You have 3.2. Okay, 3.2 amperes. Okay, current amperes. Now I2, you are going to use this formula for I2. Okay, this is equal to, this is 8, R1 is 6 ohms. Okay, 6 ohms over R1 plus R2. Okay, 6 plus 4. This is equal to, you're going to have 4.8. Okay, 4.8 amperes. Okay, so 3.2 plus 4.8, you're going to have 8 amperes if you add. So you can see on the smaller resistor, you have a larger current. On the bigger resistor, you have a smaller current. Okay, so the greater the resistance, the smaller the current that is going to flow through the resistor. Okay, resistor, resistance, resisting as the word implies. Okay, resisting, you have a larger resistance, meaning you are going to have a smaller current flowing through it. Okay, you have 3.2, you have a smaller resistance. Okay, smaller resistance, meaning the opposition is smaller, so you are going to have a larger current flowing through it. Okay, smaller opposition, larger opposition. Okay, the smaller the opposition, the larger the current that is going to flow through it. Okay, the larger the opposition, the smaller the current that is going to flow through the resistor. Okay, so you have to notice. Let me show you. If you are calculating I1, you have R2 in the numerator. If you are calculating I2, you have R1 in the numerator. Okay, you have to notice. I1, you have R2 in the numerator. Okay, when you are calculating I2, you have R1 in the numerator. You have to see the difference. So let's move on. Now, another example. Find the current through each resistor in the circuit below. You have the following circuit. Now you have 3 resistors in the parallel. Okay, you have 3. So this formula and this formula cannot be used. You can only use this formula and this formula, okay, when you have 2 resistors in the parallel. But now in this case, you have 3 resistors in parallel. Okay, so we have to find I1, I2, I3. Okay, so solution, we are going to use this formula because we have 3 resistors. Okay, more than 2. You can use this formula when you have 2, 3, 4, 5, 6, and so on. Okay, so we are going to use this formula to find I1. Okay, the current through resistor number 1. Okay, you have the total current times this. Okay, this is equal to total current is 11 amperes. Okay, you have 11 amperes. This current is going to split. Okay, part of current will flow through this resistor. Another part will flow through this resistor. Another part will flow through this resistor, and they will join at this point. You are going to have 11 amperes again. Okay, so let's find I1. Okay, total current 11. You have 1 over R1. Okay, R1 is equal to 3 ohms. Okay, 1 over 3. Now you have 1 over R1 plus 1 over R2 plus 1 over R3. This is the way we calculate the total resistance in parallel. Okay, remember, we calculate the total resistance in parallel this way. Okay, so you have 1 over 3 plus 1 over 1 plus 1 over 5. Okay, you have your total current. Okay, 11. So can you see, when you are calculating I1, you are going to have 1 over R1 in the numerator. Okay, can you see? It's different from this. Okay, so we carry on. This is equal to, you can use your calculator. You have 11 times 1/3. Now you have 1/3 plus 1/1, okay, plus 1/5, okay. So you have 2.4, okay, to one decimal place, 2.4, okay, 2.4 amperes, it's current, okay. Now, I2, you are going to use this formula, okay. Again, can you see, when you are calculating I2, you are going to have 1/R2 in the numerator, okay. When you are calculating I2, you are going to have 1/R2 in the numerator, okay, different from this. Can you see? Here you have I2, in the numerator you have R1, okay. So you have to see the difference, okay. You can remember this formula. This is the way we add resistance in parallel, okay. So we carry on. This is equal to total current 11. You have 1/R2, okay, 1/1, okay, 1/1 over, you still have the same thing, okay, the same thing, okay. This is equal to, you are going to have 7.2 amperes, okay. Now, I3, you are going to use this formula. Again, when you are calculating I3, you have 1/R3 in the numerator, okay, 1/R3 in the numerator. So this is equal to total current, okay, 1/R3, 1/5, okay, over the same thing, okay. So you have to see this different from this. So this formula can be used in all situations, okay. You can use this formula in all situations, okay. So this is equal to, when you plug this in your calculator, you are going to have 1.4 amperes, okay.